Alright, welcome back. We're going to be looking at overall solving problems using quadratic equations. And our big learning goals for the last few units have been to focus and interpret solve questions related to quadratic relations. I know I've met my learning goals if I can use problem solving skills to create and solve problems that involve trinomial expressions. And let's continue on with a quick review. In some respects, this is what we've been working towards in this past unit. And how to find a vertex when given standard form of a quadratic equation, where this is a standard form. And we've got three different methods we can use to find that vertex. We can complete the square, we can find the roots by factoring or using the quadratic formula, substituting the x value into the quadratic formula and evaluate for y. Or our third option is to use the shortcut x equals negative b over 2a to find the x value of the vertex, then just like we did before, substitute the x value into the quadratic equation. I guess the one main difference here is that when we find the x value here, we're finding the midpoint of the roots. And I think it's important to say that using those forms, you have to try and practice by using different ones and see which form or which method works best for you. Ultimately, what we've been working towards in this unit has been looking at the standard form and trying to be able to go to this vertex form, or in some cases find the factored form, which will then give us the roots and be able to give some important information about the relation. We're looking at application problems today, and specifically in this example it's a rocket which is fired in the air, and I decided to do a test for myself, which was to solve this doing the four different methods listed on those first few slides. So completing the squares, it took me about 42 seconds to find the vertex, and then a further 61 to find the roots. To factor, it didn't work out because once I got to the second step, I realized, well, there's no nice numbers which multiply to minus 30 and add to 16. This was done. At that point, I didn't bother. The quadratic equation, it took me 92 seconds to find the roots, and then a further 46 to find the vertex. And this last method here, using the x equals negative b over 2a, it took me to find the vertex. I would have started with that 42 seconds, and then it would take me a further 61 seconds. Between the two, if the numbers were nice, I really enjoyed using the completing the squares to solve, but I found overall, in any kind of good numbers, bad numbers case, that this last method, the x equals negative b over 2a, was one of the most efficient ways to do this. So I'm going to use that. Actually, you know what? These are nice numbers. What I mean by nice numbers is that the 5 and the 80 can be divided by the 5. So completing the squares is actually a good way of doing this very first question, which is the way I'm going to actually solve this. So with completing the squares, I'm going to factor out the negative 5 from the first two. T squared minus 16t minus 150. We only factor out that 5 from the first two terms. From here I need to take half of 16 and square it. So 16 over 2 squared is what number is the number that we're going to add and subtract. And half of 16 is 8. 8 squared is 64. So we're going to add and subtract 16 inside of the brackets. Is equal to, and technically I should be putting h equals negative 5 t squared negative 16t plus 64 minus 64. It's always going to be plus first. Minus 150. And this thing here is what we complete the squares to be t minus 8 squared, and then we're going to multiply this 5 times the 64 to bring it outside. h equals negative 5 t minus 8 squared. Now we're taking that 64 outside. Negative 5 times 64 is going to be 320 plus 320 minus 150. h is equal to negative 5 t minus 8 squared, that's plus 170, and the vertex in this case would be would be 8, and the maximum would be 170. So that's the max, and it happened at 8 seconds. The second part of this question says, when did it leave and hit the ground? And that's when h is equal to 0. And of course, it takes me longer to do this when I'm doing the video because I'm explaining as I go. So let's take a look at this second part of the question. I'm going to rewrite what I had at the beginning. H equals 0, except in this case, 0 is equal to minus 5, t minus 8 squared plus 170. If I were solving this, then I would just start to do opposite operations. I'm going to do this first, this second, the square third, and this 8 fourth. So in that order. So to get rid of the 170, opposite operation is subtract. It turns into minus 170 is equal to minus 5, t minus 8 squared. The second one, I'm going to take this 5 over. It's not subtract. In between the 5 and this brackets is multiplication. So I'm going to divide by negative 5. Divide by negative 5. It's going to be what? 20 plus 14. 20 plus 14 is 34. Equal to t minus 8 squared. Now I'm going to do the square root. So t minus 8 is equal to the plus or minus the square root of 34. And this is where I've got t is equal to, now the plus or minus is connected to this 34. When I move the 8 over to this side, I put the 8 first, plus or minus the square root of 34. This is not going to be a nice answer, and we know that because the square root of 34 is not nice. In fact, it's irrational, which means it's a non-repeating decimal. So in this case, if I pulled out my calculator, I got two answers. T plus root 34, which is going to be equal to, let's see if I've got it in my calculator, 13 point something, if I remember correctly. I think it was going to be 13.83. And the other answer is going to be t is equal to 8 minus root 34. And that's going to be equal to 2.169. So these are my roots. Again, it takes me a lot longer when I'm doing the explanation, which is important. With this second example, it's going to be a little bit more complex. Currently, there's 1,000 tickets for a ballet that are being sold, and the ticket price is $10 per ticket. For every 10-cent increase, there are 50 fewer tickets that are sold. We have to create a model and determine the maximum revenue can be generated by the corresponding price. And the one thing we can think about is if we end up having price, this is really important to have charts when you explain these so you understand where the equations are coming from. We've got tickets sold, and I think that's what we're going to start with. We start with $10, and if there's $10, then there's 1,000 tickets sold. If this changed to $10.10, we added 10 cents to it, then this would decrease by 50. So it would become 950. If this turned into $10.20, then this would be, subtract 50 again, 900. And what we're going to start to see is that if this is 10 minus 0.1x, the increments, we'll call x increments, then we'll add them, then the tickets will decrease by 50 for every increment of x, minus 50 times x. And you could keep going with this. I usually find that charts do a really good job to explain the model. Revenue is equal to the price times the quantity. So in this case, this is the price, and this is what we use to model it, and this is the quantity of tickets sold. So revenue will be equal to, in this case, 10 plus 0.1x times 1,000 minus 50x. Now, our initial reaction is, well, we can expand and simplify, but why do we want to do that? What we can do, if we want to determine the maximum, is we can find the roots by setting this equal to 0 and finding when these two things are equal to 0. Just to speed up a bit of time, I've transferred on to the next slide, so we're going to find when these ones are going to be equal to 0, which will tell us the roots. So one root is going to happen when 10 plus 0.1x is equal to 0. That's going to be when 0.1x is equal to minus 10. Divide by 0.1, divide by 0.1, and x is equal to negative 100. There's one root. The other root is going to happen when this is the quantities going to be set to 0. 50x, 1000 minus 50x is equal to 0. Minus 50 is equal to, minus 50x is equal to minus 1000. We're going to divide by minus 50, divide by minus 50, and x is equal to 20. So the middle of these roots is going to tell us the x value of the vertex, which we can then do is negative 100 plus 20 divided by 2, it's a midpoint, is equal to negative 80 over 2, which is equal to negative 40. Now, your initial reaction is, oh, that looks like it's not quite right, but remember, these are the increments. This is not the price. So the increments, and ultimately, when we get to the end of this question, we'll be able to answer what is the final price by substituting that x value back into this, and what we should find is that the x value is $6. But to finish off this question, what is the revenue that's going to be generated? Well, we're going to find out maybe by substituting this back in to find out what the actual value will be. We could what's the best way of doing this? Maybe we can solve for price. Price is going to be 10 plus 0.1x, but instead of putting x, we're going to put 40. The price is going to be $6. The quantity or tickets sold is going to be equal to 1,000 minus 50 times 40 times minus 40. That should also be a minus here. Is going to turn into 3,000 tickets sold. So if 3,000 tickets are sold at a price of 6, the revenue is going to be equal to 6 times 3,000, which means the revenue is going to be equal to $18,000. When the price is $6, 3,000 tickets are sold and a maximum revenue of $18,000 is created. This is our third and final question for this, and it's going to have to be quick. We may not even get to the point where we solve it. But find the maximum area enclosed by a rectangle with a perimeter of 160 meters. I don't know why my pen is doing that. I think the hardest part of this is setting up the equations. Perimeter of a rectangle is equal to 2 times length plus width. And in this case, our perimeter is 160 meters. So 160 is equal to 2 times length plus width. And in this case, we can divide both sides by 2, divide by 2, and so we've got 80 is equal to length plus width. So what this can tell us is that if we have one which is, we'll call x is the length, then that means that the width has to be 80 minus x, or we could call that length, and this would end up being the width. So our area formula is going to be equal to length times width. So area is going to be equal to x times 80 minus x. And this should be somewhat intuitive, because if we have one side which is 79, then the other one has to be 1. If the other one is 2, then the other one has to be 78. Again, I might use the method in the example 2 just because this is already in factored form. If you have standard form in solving for questions, it's important that you look for factors first. Sometimes if they're easy, it can be the fastest way of doing it. But when you're given factored form, it makes more sense just to find the roots, find the midpoint, substitute back in, and find what that value is going to be. I'll leave this one for you guys to solve. Thanks for watching, and as usual, practice makes perfect. Here's your homework, and The only way you'll get better at this is by trying different methods. Thanks for watching.